So the reason I had you do homework on imaginary numbers is because I knew that the next homework was going to be on imaginary roots. And so I wanted you to be fresh on your skills of imaginary numbers with I and FOIL and I squared and all of that so that you could do imaginary roots. All right, so there we start with the idea of the total number of roots. And you know the problem, how many you're going to have based on what the degree is. So if the degree is 3, the total number of roots are going to be 3. And these kind of roots are divided up into 3 categories. So far, you've done rational, and you have done irrational. That was what our last quiz was on. Rational are nice whole numbers, -2, 5, okay? Irrational are ones with square roots in them. Then there's a third category, and that's the imaginary. So you need to know the idea of total roots, and then they divide up nicely. Rational roots show up on the x-axis nicely. Okay, you can tell where it bounces, you can tell where it hits. Those rational roots show up nice. Irrational, they do show up on the x-axis, but they're not nice. All right, so they show up on the x-axis in an awkward way because they cross at an awkward number, 1.74239. All right, I mean, they do cross, but it is not very nice. So what you've been doing so far is with rational roots, you get to do synthetic division because that works out great. But for irrational, you need the quadratic formula. So that's sort of the past. That's where we've been. Those are the things that we have done. Now today we're going to introduce the idea of imaginary roots. The imaginary roots do not show up on the x-axis at all. But they're still part of the solution process. So if they're not on the x-axis, then how are we supposed to find them? And we still get to use synthetic division for imaginary. So thankfully, actually we can use both methods. We can do either synthetic or we can do the quadratic formula. And I'm going to show you samples of both. So you kind of have your choice. But altogether, the total number of roots can't be more than what the degree was. The other thing about imaginary roots is they always have an even number. So there's never one imaginary root. There's never 3 imaginary roots. It's either ever 0 or 2 or 4 or 6. It's always an even number. So that's something that's going to be key. So make a note of that. They always come in pairs. And those pairs are based on the conjugate. Okay, they always come in conjugate pairs. So, say you had 4 real roots were your total. Would it be possible to have 2, 1, and 1? Would that be possible? No, because for imaginaries, they only could come in pairs. They only come in conjugate pairs. So that would not be a possibility. All right, would it be possible to have 2 of those, 0 of those, and 2 of those? Sure. Okay, because that comes in conjugate pair. Suppose that that there were going to be 7 altogether. Would it be possible to have 4 of these, 2 of those, and 1 of those? Of course, yes, because they come in conjugate pairs, and which is an even number, and that would be fine. Or you could have 4 and 1 and 2, and that would be fine. What would not be fine is to have something like 2, 4, and 1. That would not work out if you were trying to add up to 7, because the imaginaries always have to be an even number, so keep that in mind. All right. That's the big idea. Now let's do some actual questions with it. All right, so given the following problem, y equals x to the 4th plus 2x to the 3rd plus 22x to the 2nd plus 50x minus 75. All right, we know that the total has to be how many? 4, okay? There have to be 4 total solutions because the degree is 4. You always have to be given in your problem at least 1 to get you started. Okay, you have to be given at least 1. So let's suppose that this problem gives you that you're going to have rational and imaginary. No irrational for this one. And that the rational ones are going to be, no, the imaginary is going to be 5i. So you have to have at least 1 to get started. Okay, great. If I've got 1 imaginary, what do I know always has to be true about imaginary numbers? Has to come in pairs. So even if they only tell me 1, how many do I really actually have? Okay, and what's the other one? Negative 5i is the other one. So I've got 2 more to go. So how do I take the 2 that I have and move to finding the 2 more that I need? And we're going to use synthetic division, just like we did on your quiz. And it works with imaginary numbers. So we're going to start, yeah.
So why did you choose 5? Did you just choose that?
It's like you were told that in the problem.
Oh, okay.
You have to be given at least 1 thing to start.
Okay.
Okay, so either you can, if you have your graphing calculator, you can look at the calculator and get 1, or this one, I just told you what it was. Okay. All right, so we're going to start with 5i as our imaginary number, and synthetic division works with this too. So let's set up our synthetic division. That'll be 1 and 2 and 22. You need a little bit more space, so space it out just a little bit for yourself. 50 and negative 75. And we're going to just do synthetic division, same. Drop down the 1, and then we're going to go from there. So the rule is take the 5i, multiply it by the 1, and carry the 5i. Now what do you do with 2 and the 5i? Not minus, this is addition, so it's 2 plus 5i. Okay, I can't add them because one is imaginary, one is real, so they just put them together. Now what do I do with the 5i on the outside? Distribute. Okay, yes, I'm going to distribute to both of those. It's not hard. 5i distributed to 2, that's easy, that's 10i. 5i distributed to 5i. Okay, I get 25i squared. What's a better way to write that? Okay, it's better to write that instead of having 25i squared, it's better to write it as 22, or to do minus 25. Okay, now let's combine those and see what I have. So I'll get rid of this. Okay, so I end up with negative 3 plus 10i. Do it again. Take the 5i on the outside and distribute. All right, what do I get? I get negative 15i, and then what? Okay, I get 5 times 10 is 50. I squared makes it negative 50. Look what happens. Sorry, I didn't line mine up. I didn't even give myself enough space, but I get 50 above negative 15i and negative 50. What happens? What cancels out? The 50s. What doesn't cancel out? The negative 15i. All right, last one. I don't have any distributing to do left. I just have to multiply the 5i times that one. Oops, I like it in yellow better. Yeah, it's like it was planned to be that way. All right, when it multiplies, we get negative 75i squared, but rather than write the I squared, let's make it positive 75, which means I end up with 0. And it's like it was meant to be, and it totally was. If you don't get 0, what does that tell you? You did something wrong. Okay, you messed up somewhere, and you got to figure it out. Okay? All right, well, it worked for 5i. What's it going to work for also? It sure will. So it's going to work for negative 5i too. And the second one, I promise, goes way faster than the first. The first one is always, takes the most numbers, but we're going to do it with negative 5i. All right, drop. So we drop a 1. We get negative 5i. See, I promise the second one is always easier because what happens right away cancels out the 5i and we're left with 2. And then we multiply that and we get negative 10i, and what happens right away? Cancels out and I'm left with negative 3. And then we do it one more time and we get positive 15i, not I squared, just I, but it perfectly cancels out with the one above and I got 0 again. So I just did synthetic division twice, which means when I reattach my variables at the end, what power am I reattaching to these 1, 2, negative 3? 1x squared plus 2x minus 3 equals 0. And what do I do to that? What am I trying to find? Let's review that again. We just did this. Why? What am I trying to figure out? Yeah, let's go back. I'm looking for what these 2 rationals were. I had the 2 imaginaries. Now I'm trying to figure out the 2 rationals. And so I get to this point, which is a perfect star factor. Star factors are x plus 3 and x minus 1. Set each of those equal to 0. So x is negative 3 and x is positive 1. So if I were to summarize, I now know my 2 rational roots. I know my 2 imaginary roots. So my 2 rational roots turned out to be negative 3 and 1. My 2 imaginary roots that I started with, those were 5i and negative 5i. And so my final factors is 1 parenthesis for each. So x plus 3, x minus 1, x minus 5i, x plus 5i. So you tell me, where does this graph cross the x-axis? Okay, left 3 and right 1. And it's not crossing anywhere else. And what shape should this be because it's a 4? Kind of a W-ish shape is what they look like. Okay, so it's supposed to be a W. Both sides are supposed to face up. And it's only supposed to cross at 3 and negative 1. So if you were going to make a graph of this, 1, 2, 3 over here, 1, but it's got to be a W shape. So your graph is going to look something like this. But the second dip of the W doesn't ever touch the x-axis. All right, let's try another one. How would you totally check, how would you ultimately check your work? Right, without a graphing calculator. Foil, right? Because the factors can be foiled, and what should the foiled end you up with? The thing that you started with, okay? That's how you can check your work. All right, let's try another one. Okay, so if y equals x to the 4th minus 5x to the 3rd minus 3x squared, 43x minus 60, crosses the x-axis nicely at -3 and 4. Find the other roots. Find the remaining roots. Well, how many remaining roots are there? How do you know there's 2? Okay, because the total is 4. So again, this total is 4. We were given the rationals to be -3 and 4, which means my other ones, I don't know. They're either irrational or they're imaginary, but there's 2 more out there. No problem. I'm going to start the same way. Because I've got 2, I'm going to do synthetic division twice in a row. So we'll just, it doesn't matter what order you do them in. You could start with a 4, you could start with the -3. That doesn't matter. But you should get what for your answer? 0. If you don't get 0, something's not right. Like, remember Haley wasn't getting 0 and it was because, oh, she's asleep. All right. Anyway, it's because she forgot to insert the zeros and that was why. She had a big volleyball game yesterday. Okay. All right. So, carry the -3. We're going to get -8. That carries a 24. That gives me a positive 21. That gives me a -63, which is a -20, which is a 60 and 0. So it all works out fine. Then I'm going to do it again. And hopefully it'll work out at the second time. So I'll carry the 4, get a -4, get a -16, which gives me a 5, get a positive 20, gives me a 0. Okay, so I'm good. I'm golden. Everything turned out great. I still have 2 more to go, and because I did synthetic division twice, I reattached those variables, and I've got 2 more answers that are going to come out of there. Unfortunately, star is not going to work. It looks like it maybe should, because we've got a 5 and a -4, and it really would be nice if I could figure out 1 and 5 to work for that, but I'm not going to be able to get a -4 out of that. I mean, if I made the 5 negative, that would work for the -4, but now that messes up the 5 at the top. So star doesn't work, which means I need to use the quadratic formula. So x is -b plus or minus square root -4 squared minus 4 times 1 times 5 all over 2. So I'll do the math for you a minute. That's 4 plus or minus 4 minus 20. So under the square root, yeah, thank you. I'm going to get -4. That's what I was thinking. 16. I'm going to get -4 over 2, which is going to be an imaginary. So I'm going to have 4 plus or minus 2i over 2. So separate it so that you can reduce 4 over 2 and 2i over 2, which gives me 2 plus or minus i. So my answers ended up to be imaginary. So the 2 rationals that I started with, so the 2 rational roots, oh, we're so close, -3 and 4. The 2 imaginaries were 2 plus I and 2 minus I. And then you can write the final factors for that. So final factors, x plus 3, x minus 4, x minus 2 plus I, x minus 2 minus I. Whew, got it done.